So next up is Juha Holkkola from FusionLayer talking about the future of IP resource management.
Yeah, thanks. Is the mic working? Great. It's working, right? Okay, you can all hear me. Excellent. So yeah, to introduce myself, my name is Juha Holkkola and I'm the co-founder and chief executive of FusionLayer, or FusionLayer Group as we are these days. There's actually a couple of companies within the group. We've been traditionally doing DNS, DHCP, IP address management, some network automation types of things. And actually there's quite a few customers, existing ones, as your members and also here present today. And we've been actually also expanding towards radio access networks, so a bit more to the mobile direction. There's actually some news around that over the coming weeks. And then actually also looking into the future, we've been looking at how, the sort of, let's say, infrastructure that will be used to run, the internet, the internet services of tomorrow, how they will be evolving and what it means to us as someone who's coming into this from the connectivity and IP perspective. And, I think the same applies to many of you as well. So, how does it work?
Has it run out of battery?
No, now it's working. Great. Good. So basically, there's a couple of things we see that are actually happening right now. One of them is actually where the computing happens, and that's of course important also from the connectivity perspective. And interestingly, when this deck was being prepared, I had no idea what NVIDIA and Nokia and Cisco and others are doing in this space. But as you noticed probably in the news last week, so there were actually two things that I think will impact this quite a bit. So the other one was actually the announcement by Nokia and NVIDIA. So the idea is that actually to the run side of things, Nokia will be introducing NVIDIA chips. And what that actually means is that, if traditionally computing has been happening, in data centers, in public clouds, places like that, so it will gradually move towards the edges of the network. So it actually happens closer to the end users. And then actually another thing which was left at a bit less let's say, attention, at least here in the Nordics, was actually the announcement with Cisco and NVIDIA. So basically what they're doing now is they're partnering up on the AI factories, which are these huge sort of data centers, I guess you can call them, that are specifically designed to run various kinds of AI services and workloads. And so when you actually put this together, if traditionally what we've had is data centers and then basically public clouds increasingly, so we think actually the model will slightly change, and it will be AI factories and cloud edge nodes that will actually start gaining traction over the coming years. And this is actually, there's no event where no one would talk about AI. This is no different. So we think actually another big change, in addition to the architecture on the high level, is actually the fact that we think AI agents will have a role when connectivity services and then applications are being set up. So, if I have a business need, I need to set up, a new node somewhere. Maybe there's some use case that needs new connectivity, new capacity, new applications, new AI, what have you. So what actually happens is AI will be asking for those things. And in practice, it will be the AI agents that actually will request for those resources through some API, through some orchestration, and that is an area that is shaping up. So that's something we see happening as well. And then, of course, when you put all these things together, it basically means that the things that we have in place today probably won't be able to accommodate all the different things we need to be doing in the next, say, 2 to 5 years. So there's going to be change ahead. And basically, from the IP perspective, the interesting thing is, I think actually IP isn't going anywhere. The connectivity services that we are using, it will all be based on IP. But basically, how it will be used and how it will be run, how it will be operated, how it will be managed, I think that is actually something that is going to be changing. So I already mentioned on the top left side, you have the AI factories. I'll come to the practical details in a bit, but they are actually a different kind of beast. And from the connectivity perspective, they are useless without proper connectivity over the public internet. So that's an area where we think stuff will happen. The other one is edge clouds, partially because it's actually going to be very dynamic. So if you think about edge cloud, it's all about kind of, let's say, need-based computing, having extra capacity when you need it, and then being able to decommission it when you don't need it. So it's going to become way more dynamic, way more fluid. And again, if you think about from the connectivity perspective, it's going to change how things are managed. Then security and automation. Well, in this day and age, you cannot spin up these new computing nodes with connectivity, with network functions, without having security in place. So obviously, that's something we will need to address. And then actually all the way to the, let's say, the kind of the physical level of things. So not many people have heard about DPUs yet, but what DPU is basically, traditionally we had CPUs, which are used for, kind of traditional application processing. Then we got GPUs, which were originally used for gaming and for kind of visuals and graphics and stuff like that, and now increasingly they are used for AI because they are very good at processing tokens at scale. But actually the next one that is actually being now standardized within the Linux Foundation is actually DPUs, digital processing units. NVIDIA is working on this, Intel is working on it, Marvell is working on it, AMD is working on it. And the basic idea is that all the I/O intensive stuff, which is networking in general, security, maybe some database things, those will actually be offloaded from the chip, from the DPU, from the CPUs and the GPUs. So there's actually going to be new chips that you connect to, and all the I/O intensive stuff, all the processing will happen there. And they're basically, if a traditional way of doing network services is basically a rack in which you put some appliances into it, then what you have here is actually a chip which is full of containers. And what it actually means is that, all of these infrastructure bits and pieces, be it routing, be it, security services, be it network functions, whatever it is, it will be containerized very likely. And you, of course, have to find a way to put this stuff into place in a fluid fashion. So this is how things are changing. Now, basically, to give you a practical idea of how it looks like, this is actually, I was in Paris in June. It was an event organized by NVIDIA. I was there, I actually saw one of these GP200s in real world. It's actually quite impressive. It's proper, good-sized rack with golden plates in it. It looks tremendously nice. But the interesting thing is how much capacity those things have. So an individual rack, it actually has more computing capacity in it than a pre-COVID super computing data center, the whole data center. And if you think about it, they are now building new these AI factories where you can have dozens or hundreds of these racks. So basically the amount of the computing capacity that is being set up, it's going through the roof. Now, the way they actually do it is they put these golded plates into the rack, and actually they have to connect all those plates and all that capacity, they actually have these copper sort of bulks, huge bulks of copper which weigh like 30 kilos each, and they are the backbone there. They are inside them. Every plate gets connected to these copper things, and actually each copper thing in there has more capacity in them than the current internet backbone. So there's a huge amount of also network capacity inside these racks, and so it's basically very impressive stuff. But what the NVIDIA guys told me is actually, when they look at it and when they're actually building these new AI factories, actually none of it is of any use and it's of no value unless you are able to connect it. And to connect it, you need internet, you need IP, you need to organize the connectivity somehow. And I mentioned DPU. So what NVIDIA is actually doing is in each plate, they actually have 18 of those high capacity computing plates per rack. And for each one of them, they actually have 2 DPUs that do all the network functions So there's actually 36 Bluefield DPUs inside each rack. And then if you think about it, you have dozens or hundreds of those racks. So we're talking about thousands of DPUs, which are basically, these chips that need, the routing software in it. They need the network functions in them, the security functions, all of that. And so, how to actually organize all this and how to manage all that, this is actually something that is currently still being worked on. So that's something, it's definitely good for IP, but what we actually think is the way this gets managed and, kind of done in general, that is something that is changing. I think, if you go back to the most environments today, be it data centers or network environments or, connectivity, it's typically, there can be some automation these days to some extent. I mean, it's still quite manual, but I've actually seen some of the tier ones, for example, here in the Nordics, they've been looking at, Salt, or they've been looking at Ansible or, Chef or Puppet or something to actually kind of automate individual workflows and processes. And, generally speaking, that's all very good. It's often a good starting point. But the thing is, it's oftentimes, it's not really that you're automating the entire process, but instead, oftentimes, it's more to do with automating individual tasks. And of course, if you think about the magnitude of the change, it basically means, the whole thing needs to be kind of rethought. So just to give you a practical example, right now we're actually sponsoring, it's a research initiative by ESA, the European European Space Agency, and then Fraunhofer in Germany. And what they're actually doing is they will be sending European shuttles to the space, to the moon in 2027. And what they're actually working on right now, because, to put this stuff, put people and put, well, astronauts, however they're called, I don't know what a Euronaut, I don't know. Anyway, to put people in the moon, what they intend to do is they intend to set up connectivity. They intend to set up everything basically. So what you have is AR, VR, XR, all of that in space. Now, the question is, well, okay, so how exactly are you going to do it? And basically, what they are now working on is they are developing the tools and the methods that will be used to actually to be able to deploy stuff in the space. And a couple of things that it involves, there's going to be a lot of automation that we know already. There's also going to be lots of simulation. So a thing called digital twins. So basically what they do is when they build these kind of connectivity stacks, which have the, the routing, the network services, functions, all of that, it's going to be built automatically, it's going to be configured automatically, and it's going to be sandboxed automatically. And it's going to go through simulation so that you actually build and set this up automatically, and then you can actually test in sandbox that everything works. And once all of this works, then you deploy it. And this is how they intend to do this in a few years' time. There's actually other industry initiatives that are kind of going to the same direction. For example, SEMA with VTT, some other stuff here in Finland, for example, too. But there's definitely some change there. As to what FusionLayer, we as a company have been doing in this space. So we've actually been, for the last, I'd say 18 months, we've been actually working on a new R&D initiative with Business Finland, which actually aims at automating the onboarding and the instantiation of new network and infrastructure services. So essentially, the work is based on RFC 8572, that's secure zero-touch provisioning. The basic tasks that we are able to do now actually is we can do zero onboarding of new devices. So what this means in practice is when you put like a white label something, a physical device into a data center, we can actually automatically do the configuration. We come from the DHCP background, so that's actually the easy part. But we can also do the update, all the security updates use bootb to actually just apply them on those servers. We actually use STTP for that. We also have service catalogs that you can use to actually kind of onboard all the different functions. It can be software-based routing, it can be different security functions, DNS, DHCP, web services, what have you, but you put them to a catalog and you can deploy them remotely on zero-touch basis. So just to give you an idea, we did a kind of this proof of concept thing with Supermicro in the Netherlands, and then Kumukor, which is a private 5G provider here in Finland. And we were actually able to, we took, a Supermicro device. It was mounted in a rack powered on in Netherlands, and we had our experts running in Germany. And actually in less than 2 minutes, the whole device was onboarded automatically. And we had also installed and configured the whole 5G core into that box. So it's very fast. It's like previously when people were setting up 5G, it would take, weeks, months, even years to actually get those up and running. But by automating it and using the STTP standard, we have some proprietary bits and pieces as well, but it actually speeds things up considerably. And then you can actually do the lifecycle management as well. So if you're serious about providing services, you can onboard the new devices, you can drag and drop the services and network services, functions, security, all of that into those boxes in minutes, and then you can do the lifecycle management as well. So you can monitor them, and then you can sort of decommission them at the end when you no longer need them. And by the way, actually this lifecycle management, I think also for connectivity services, it will become more important over time, because the shelf life of anything is going to be a lot less than before. So if traditionally you bought a box, you mount it, you run it for 5 years. When it's software based, when you deploy it as containers on some hardware somewhere, it will actually the life cycle will be much shorter. So that will have a big change there. And we are not actually in this alone. So in Finland, often of course you've had many companies with guys who have propellers in their cabs, and then they come up with all sorts of stuff. But actually, we aren't working on this alone. So we're actually members of the Linux Foundation, and more specifically, we've been very active in a group called OPI project. That's Open Programmable Infrastructure Project, and we are actually the only European company within the OPI. But other companies that are part of it, they include NVIDIA is there, Intel is there, AMD is there, Marvell is there, F5 is there, Red Hat is there, a few others. So basically, what we are doing together is currently defining the blueprints for the open programmable infrastructure of tomorrow. And that will be based on DPUs, and it will be based on STTP, the secure zero-touch provisioning standard. And as part of this work, we've also, one of the things we ran into with the OPI guys was that actually there was no STTP clients. There was no STTP servers, production grade either. So we actually developed one. We open sourced it. It's Apache 2.0. It's available to anyone at GitHub. You're free to go and try it out. But basically, yeah, like I said, it's actually, if you're interested in this let's say next generation of infrastructure and the programmable future that lies ahead, then OPI project under Linux Foundation is definitely something to have a look at. You can find it from it's not there, but it's www.opiproject.org is the address there. So check it out. It's basically it's good stuff. But yeah, I think that's really in nutshell what I wanted to say. I had 20 minutes. I've pretty much used it almost exactly.
Yeah, that clock is not in the right time.
Okay.
You have 1 minute left. So
I have one. Okay, good. So yeah, so basically, what I really guess I wanted to emphasize is I think actually, a lot of the IP connectivity and IP services, they've been reasonably static, and they've been taken for granted, and oftentimes they haven't been kind of in the front and center of the stuff that gets done. But I guess my point really here is that I think that will change, because IP connectivity, it's absolutely critical to this to the future of AI, VR, XR, all of that, low latency, low jitter connectivity, reliable, it's an absolute must. And as these architectures become fluid, it means that there will actually be new challenges for the IP connectivity crowd and people and professionals to actually figure out how that can be done reliably. But I think there's a bright future ahead. So, I think you all will probably run into some interesting stuff over the coming years. Oh, okay. So 4, 3, 2, 1,
time's up.
0. Thank you. Okay, good. Thanks.
And you will be staying here?
Huh?
You'll be staying here for dinner?
I'll be staying for the end of the session, then I'll
All
be
right.
jumping
So
off.
need to catch him quickly after the
Yeah,
session.
we'll be happy to have a chat.